Okay, in the last video we talked about value returning functions, talked about argument lists, and function prototypes. The word I was looking for was early binding. That's what happens on the first couple of passes when the loading program is talking to the operating system and allocating memory for your variables and your functions and all, and actually your program as well. It has an actual memory location where it resides. And so early binding uses these prototypes to inform the operating system on some memory requirements, because these allocate memory as well. So I have local variables or arguments that are local to the method that it has to deal with. Okay, you can deal with these. This is late binding, so it's going to do all this. Say, okay, expect this, and we won't get into that too much, but that's basically what's happening. And so you have to have these. In case I didn't tell you, these have to be here, and you define your functions down here. So I basically have 3 in my prototypes list and 3 function declarations, and we've done the value returning function. So now I've commented out all of that, and we're going to deal with our void function. I have 2 implementations of this, and you'll see why in a minute. Remember from the last video that these arguments are simply copies that are passed in by value. They're just copies, all right? That's the default. Unless you override that, it's going to pass copies in. All right, so I have 3 variables that are defined within my prototype and within my method down here. And notice the void. That means you don't return anything. If you see that, that means there's nothing to return, all right? And you'll see that in my invocation or call up here. So it's a void function. It has the same name, and you've got double len, double with, double a. Now again, I changed the names of these because they're different. They're copies. Now if I wanted to come in here, and let me show you about IntelliSense. When I typed these in, I typed in calc area, and of course it gives me an opportunity to hit my tab key. As soon as I put in, whoops, excuse me, that's got to go in main, my fault, somewhere else, can't go here. As soon as I put that in here, try it again, calc area, all right, IntelliSense has called that, has caught it. Now notice I've got one of 3 implementations, and that's the polymorphism we were talking about. It allows me, based on the number and type of arguments, to use the same name and call different ones. Now, let's see which one I want here. I want number 2 of 3. All right, that's 3 doubles. All right, so I would type in maybe 2 point. I would type in variables. I'm just doing this to show you. So see how it moves from one to the other as soon as, whoops, that should have been a comma. As soon as I put in the arguments, and so it'll tell you if you got something wrong. And that's how you use IntelliSense. It'll define an object, or it'll show you what the object expects. All right, so I put my breakpoint here, and I've got a breakpoint here, which it should call this one. So let's go ahead and run it. Hopefully I don't have any errors, and see what's going on. Okay, so I've got 2 and 2. All right, it broke. Notice these are undefined because they don't exist in this in here, right? They are local to that other method, so I'm gonna just leave those. But area does, and so does calc link. Or this one doesn't because we're not using it anymore. We're using a different one. So let me delete that, and let's add. Well, that doesn't return a value, so there's nothing to add. All right. So there's area set to 0, width is 2, and length is 2. These are copies that we were about to pass in. So I'm going to press F10, and this should execution should jump down to this method, or this function. And it did. And notice that len has a copy of 2, width has a copy of 2, and a is 0 because there was nothing in it. So let's so you can see that down here. Let's press F10, and here's a, right? What does a equal? 4. Okay. Now press F10, execution should jump back up here, and it did. And now it jumps down to this C out, and let's see what we get. Wait a minute. I put in 2 and 2, but I got back 0. Why is that? You ask yourself, why didn't I get 4? Well, there's a reason for that. I passed in copies of what was here. A and wid and len hold copies. They only exist while this method or function is active or alive. Okay, so A is fine right here. It had 4, but as soon as execution returned back up here, this is a non-value returning function, it didn't impact area. So area was still 0. So this is not going to work. If I want to change one of these values in here, which I do want to change area, I want area to be outputted right here. Well, area is not being changed because it's being passed in by what? By value. We need to change that. So I created yet another function to address that. Now let's look at something called by reference. Now some of you remember this from 150. If you want to override the standard default way of passing in arguments to methods or functions, you have to do it by reference. What does that mean? And there are different ways of doing it. In C++, C#, you can use a reference variable or a pointer. I'm using a pointer to memory here. That just tells it, don't take a copy of what's in here. Point to the actual physical hexadecimal address in memory and pass that in. Okay, why we want to do that? Well, I'll show you in a minute. Anyway, the only difference between this one and this one is this has a pointer to a memory location, right, called A of type double. All right, now you'll notice that down here, this is still a void function. It doesn't return anything. I have that pointer, and I also have a pointer here which will allow me to point to where? Well, we'll see. I'll show you in a minute. Let me do this, get rid of this. All right. Okay, so let's save it, run it again, see what we get. All right, we're going to put in 2 again. All right, execution is paused. Here, notice I have a reference here. What I'm saying is I don't want to pass a copy. I have to pass the memory address. So I'm using a reference operator, or what they call an address of operator, to grab the hexadecimal address of this variable, which is defined here. Okay, remember that all these variables start with a hexadecimal address in memory. That's why when I use length in assigning a value, it's pointing to an actual hexadecimal address of memory, or a piece of memory located in RAM that will hold a double. Okay, and it knows how many bytes that is. What's 16 by 8 bytes? I can't remember. They're all different. I teach so many languages, I can't keep up with it. All right, so here we are. We're at our function call for this last one. I'm saying I want you to pass in a copy of length and a copy of width. I didn't override those. Those are still by value. They're copies. Doesn't matter what I do down in here to them. I could multiply by a gazillion, and when I got back up here, length would still be 2 and width would still be 2, because those values are temporary copies that only exist on the stack temporarily. This, however, because of this pointer, is, and I'm saying grab, using this reference operator, address of operator, grab the address of this variable and pass it in as a pointer to here. So what A is pointing to is area's memory location. See that? So that means that the variable area has 0 in it, but this has the hexadecimal address of area in it, which means whatever I do here, I'm going to be pointing to area. So A, star A, points to the same memory location as what? As area. That's called passing by reference. Now that's a very powerful thing. Okay? That's why it's not the default. You have to override that behavior and tell it to do something different, and you can really get in a mess if you don't know what you're doing. Memory leaks. You could point to a protected memory location in memory. It's not so bad as it used to be. The blue screen of death was usually the result of that and the computer crash, so you had to reboot. Now they have some really good ways around that, but you can see why this language is preferred by this and assembler by people who write viruses, right? You can get down to that low level and do some nasty things with it. All right. So anyway, let's press F10 so we can execute the next line, which is going to jump down to this. Notice that IntelliSense figured out, or the compiler figured out which one of these to call. This one as a reference. It didn't call this one, even though it has the same number, so it jumped down here. What does A equal? Ooh, what in the world do we have here? Well, what we have here is a pointer to hexadecimal. See that? That X, that's a hexadecimal value. All right. That's the memory location. Next time you run it, it's going to be different because it always changes. All right. Now what I'm saying is, at this memory location, I want you to take this value and stick it in there. Where is this memory location? It is exactly the same as that pointed to by area. They point at the same thing. They're not just copies. These are, this isn't. Now let's see what happens when we execute that. See, A still has that memory address, but it's sticking in that memory address 4.000 ad nauseum. Now, let's see what happened to area. It automatically changed. Now, where did it change it? It didn't change it up here. It changed it as soon as that executed, because A, the pointer to A also points to area. I wasn't even in main when that happened. Okay? So now, let's see what happens. Alrighty. There it is. Notice that that is correct. 4. All right. Now let's decomment all this stuff and let's run it a little bit. And I'm going to send this to you so you can play with it. I mean, this is what we call learning by example, by repetition. All right. So I'm going to take this one out. This is a value returning call or invocation. Why? How do I know that? Because I have a variable on the left, and I have an assignment operator, and that variable is of what type? It is of type double, okay, which is what that's going to return. I also know that I have a return function here. I'm returning a return statement. What is A? It's a double. This returns a double. That has to be a double, or you could have done lim times width. They're both doubles, temporary copies up here, right? Okay, so I had to reinitialize that because I don't know, out of habit, I guess. All right, so I've got everything set up. I'm going to take my breakpoints off, and I expect you to set breakpoints and set watch windows and see what is going on. If you want to learn this stuff, you got to do a couple of things at this point. You got to spend more time on it out than you're doing in class. All right, you got to eat, breathe, and sleep it if you really want to get good at it. I mean, you can get through the class, or you can actually learn it and really know it. The way you do that is to work your butt off. Don't care who you are or what you think you know. It takes work, period. All right? Believe me, if I can do this, you can too, but I spent a lot of time doing it. You may not. Maybe this will help you get through it better than what I had, and that's my goal. I hope it is. All right. So let's run it. Again, these are your function declarations, and where do they occur? They occur below main. Don't forget that. There's your closing curly brace for main, and don't put a semicolon here. You will have trouble. I just did that a while ago when I wasn't on camera. I couldn't figure out why it wasn't working. That was it. All right? Because I'm not ending this. This is a code block that's associated with each one of these, right? Now you have semicolons at the end of your lines. All right. Notice here I do have semicolons because that's the end of this. This is just your pre-compilation function prototype. Now these go where? These go above main. I have some comments already in your little template for this very thing. If you'll notice this, function prototypes and function declarations. Now this is a function call. For what kind of function? A value returning function. This is a function call. For what kind? Well, there's no assignments, just the name. That means what? It is a void function. And I think some languages have a call statement. It doesn't appear that C++ has it, but some do. You don't need it. It's optional anyway in most languages. Here I'm calling one that's just passing by the standard default by value. What's area going to be when I get back up here? It says, why doesn't this work? Because it's just a copy. Area is 0. There's nothing passed in to change this area, so it's still 0 when it gets back. Doesn't help you any. Here I'm using the address of operator. It's at least they call it that in VB and C#. It's a reference operator here, but all it says is get me, rather than the value stored there, pass in the address of this variable so that I have access to it here. passes in the memory of it. We've already showed you the indication of the hexadecimal value stored here. That's why you have to delineate this as a pointer to memory. This is the syntax you have to do, and this is very, very interesting stuff, okay? All right, let's run it, compile it, and run it, see if I get any errors. Oh, okay, so I'm going to use 2 again, and 2 again, and it's going to output 4. That was my value returning function. This is my void function, yet it didn't pass anything in any differently than the default, which was what? Was by value. So I didn't change area because area had, that function had no access to my area variable in main, so it stayed 0. That's what it was always. See? There's area here. Nothing changed it here because we just passed in a copy of 0 down into the method, so there was no way for it to change it. So when it came back up here, still 0. Now, we address that here because if you'll notice the prototype up here has the asterisk, which means it's a pointer to type double. It points through a memory location. That's what that asterisk means. Don't expect a value other than hexadecimal address to be stored there. All right? And so we took care of it here. We took care of it here, and we passed it in. We used the address of operator, which says override the default way of passing in a copy of the value stored at area and pass in the actual hexadecimal address of the variable area, which gives access to that memory here. That's why we got a 4 back, because that's what we were doing. Let's see. I think that pretty much covers it. You'll need to look at this. These are pretty in-depth videos, but you'll need to watch them several times and play around. I'm going to send you a copy of this. I expect you to take a couple of weeks, outside of class going over this. We're going to keep moving, but this is something you got to know. You just have to know this stuff, okay? This is really important for your future programming endeavors. And this is probably one of the hardest things. Now, arrays, when we get into arrays, they're passed by reference by default because it has to. I mean, you can't pass tons of data into something like that. And we'll talk about that when we get into it. It's pretty interesting. Okay? Got it? Good. See you in class. Well, not tonight, but sometime.